This is a video lesson for section 8.5, applying the Pythagorean theorem and its converse. So we're going to be talking about the Pythagorean theorem today. But before we do that, to work with the Pythagorean theorem, you have to understand what a right triangle is. So a triangle, everyone knows what that is. A right triangle is a specific type of a triangle that contains a 90-degree angle. It has only one, because you can only have one, but it contains a 90-degree angle. So one of the angles is 90 degrees. It's a right triangle because it has a right angle inside of it. Now, just like any other triangle, a right triangle has three sides. It's got one leg, it's got another leg, and then it also has a third leg called the hypotenuse. The hypotenuse is the long leg or the long side, and it's always the long side. So you have two legs. They can be the same length, they can be of different lengths. One can be longer than the other, but they both are shorter than the hypotenuse. So the hypotenuse is the long leg of the triangle. It's one of the sides, it's just the longest one. So if I were to label this particular triangle using three variables, and if I were to choose the variables A, B, and C, I would assign variable A to one of the sides, variable B to the other side, and variable C always goes with the long side. The A and B are technically interchangeable. Either of the short sides could be A or B. Typically, the right way to write this is A is the shortest side, B is that middle side, C is always the long side. But the A and B, you can interchange them. The only one that you can't interchange is the C. The C is always the long side or always the hypotenuse. That being said, the Pythagorean theorem has this particular formula that you have to memorize. A squared plus B squared equals to C squared. So the Pythagorean theory states that, or the theorem, if you take the square of one of the short sides, you add the square of the second short side, they have to equal out to the square of the long side or the hypotenuse. So the sum of the squares of the two short sides have to equal out to the square of the long side. So that's essentially the Pythagorean theorem in a nutshell. So now let's do an example. Let's say I gave you this particular triangle over here. And I told you that, let's see here, C equals to 7, B equals to 6, and A is unknown. So we don't know what A is. Every single Pythagorean problem starts like this. You have a triangle, two of the sides are known, one is missing. In this case, we know one of the short sides, we know the hypotenuse, we're missing the other short side, the shortest side technically. So the first things first, write down your Pythagorean theorem. A squared plus B squared, equals to C squared. And then next step is plug in everything that you know. So we know what C is, right? It's 7. So that C is going to get plugged in over here. We know what B is, it's 6. So that gets plugged in over here. We don't know what A is. So that's going to stay as is. And that's an A, not a 9. Sorry. Once we do this, we end up with A squared plus 6 squared equals to 7 squared. Okay, so far? All I did is I substituted what I knew. Then I want to crunch my numbers out. So A squared remains A squared. plus 6 squared, that's 36, all equals to 7 squared, which is 49. Now I'm solving for a, which means I want to subtract 36 from both sides. If I do that, a squared equals to 13. Now we're pretty close to being done here, except we want a, not a squared. So how do we get a? Well, if you remember from section 8.4, I told you that the square root and the power of 2 are opposites. They cancel each other out. So if I square root that a squared, then I can cancel out its root, or its power of 2. Perfect, except I have to balance this equation out. Whatever I do to one side, I have to do to the other side as well. It's a requirement, a mathematical requirement. You can't do something to one side of the equation without doing the same thing to the other side, because otherwise you're fundamentally changing it. We don't want to change it. We just want to get rid of that power of 2 in the a. So we square root both sides. The left side to get rid of that power of 2, the right side to balance out the equation. Now once you do that, we know that the power of 2 and the root, they cancel each other out. So all you're left with then is a equals to, that should be an arrow, a equals to root 13. And that's your answer. So that's essentially how to solve a problem like this. Any Pythagorean theorem problem will have a triangle with 2 sides given to you, the third side missing. You plug in the 2 sides that you know, solve those, so mathematically crunch those out, simplify if necessary, and then once you get to this point where you have the missing side squared equals to a number, you square root both sides to get rid of that power of 2 on that missing side, and that's your answer. Now sometimes you'll have to simplify the answer as well. In this case it's root 13, and 13 is a prime number, so we're done. Sometimes you'll have either a perfect square underneath the root, which easily cancels out, or sometimes you'll have something that contains a perfect square, which means you'll have to simplify that particular root. But we've already done that, we've covered that, so that should be fairly easy. But essentially every single problem is going to solve pretty much like this one. So that was the straightforward Pythagorean theorem. Now let's look at the converse, the opposite of the Pythagorean theorem. So the Pythagorean theorem only works with right triangles. So if you have a right triangle, you can apply the Pythagorean theorem. But the reverse is true as well. The reverse says that if the Pythagorean theorem works, if this works, if a squared plus b squared equals to c squared with any 3 sides, then you have a right triangle. If true, then it is a right triangle. So if the Pythagorean theorem is true, so if I were to give you 3 sides and you were to plug them into the formula, and the formula worked out where a squared plus b squared equals to c squared, then you have a right triangle. If it doesn't work out, then you don't have a right triangle. So what does that actually look like? Glad that you asked. So let's go ahead and do a problem like this with the reverse. Let's actually do 2. So number 1, we have 3 sides, 8, 15, 17. So that's given to us. The only other thing that you need is the Pythagorean theorem formula, which is up here. You should have memorized that. Now we're going to substitute this in. So I'm going to assign each side one of the variables. Typically, again, I like to say that the short side is a, that the middle side is b, and the longest side has to be c. These two can be interchangeable. The long side cannot. So then I'm going to plug these in and see what I get. So I'm going to get 8 squared plus 15 squared equals to 17 squared. Alright, so let's go ahead and mathematically work this out. So 8 squared, that is 64. 8 times 8. 15 squared, that's 15 times 15, which is 225. 17 squared is 289. So are these the same? Well, you'll have to add 64 plus 225, but if you do, you will find out that indeed 64 plus 225 is 289, which is indeed equal to 289. So it works out. These three sides fit into the Pythagorean theorem. They check out. So you can say, that's supposed to be a check mark. So you can say that this is a right triangle. This is a right triangle. Good. Let's try another problem. Again, I'm going to give you three sides. The three sides are as follows: 5, 8, and 9. Again, I'm going to assign each side a variable. The short side, I always like to say it's A. The long side, I always like to say it's B. And the middle side is B. And the long side always has to be C. Again, the first two, they can be interchanged, but the long side always has to be C. That's the only requirement. So I technically could have said 8 is A and 5 is B, but the conversion is that shortest is A, middle is B, and longest is C. So if possible, keep it in this order. It's going to cause you less confusion down the road. So now I'm going to plug these numbers in. 5 squared, which is A squared, plus 8 squared, B squared, equals to 9 squared, which is our C squared, according to the Pythagorean theorem. Then I'm going to crunch my numbers. 5 squared is 25, 8 squared is 64, and 9 squared, well, that's 81. If you add these two together, so if you add 25 to 64, you are going to get 89, which does not equal to 81. So in this case, this three sides failed the Pythagorean theorem. So not true, which means you can conclude definitively not a right triangle. This might not even be a triangle. We don't know that for sure based on what we've done so far. All we know for a fact that number 2 is not a right triangle. Number 1 was a right triangle, number 2 is not a right triangle. So that's about it for the Pythagorean theorems as far as what you need to know. So the straightforward way of doing the problem, and then which is like this, where you're given a triangle with three sides, you plug it into the Pythagorean theorem and find the missing side, and the reverse or the converse, where they give you three sides and they're asking you to show them if it's a right triangle or not, and you plug in all the given sides into the Pythagorean theorem, crunch it out, and see if one side of the equation equals to the other side of the equation. If it does, it's a right triangle. If it does not, then it's not. So thank you very much for watching, and have a nice day.